So in this video, we're going to be going over questions 26 through 32 off the review. Question 26 is asking us to circle which of the following represents a linear function, and if it's not a linear function, indicate why it's not linear. So some things to keep in consideration when we're talking about identifying linear function is we want no exponents. We must have the x variable. X is our independent. And we cannot divide by variables. And then the last thing is we also cannot multiply by variables, or not multiply variables together. So you can multiply, but you can't multiply a letter with a letter. So we come back and we take a look at our first equation. We see there are just no exponents, which is good. So there's a check. We do have an x. We are not dividing by any variables, so the x is off to the side. And we are not multiplying the x with another letter. So this first one is a linear function, so I'm going to go ahead and circle it. The second problem, or the equation, we have f of x equals x squared, and we see we have an exponent of 2. We cannot have exponents, so this is not a linear function because of that exponent. Then we go into the verbal part. In looking at the verbal part, there's some key words that we want to remember, and those are going to be constant, rate of change. That's telling us that we have the change in y and the change of x gives us linear. If you see the word per, that means we have a constant rate of change. And then some geometry terms, perimeter and circumference, because that's talking about the distance around an object, which was linear. So we come over and we take a look at our verbal situations, and we see during an 18-mile kayak race, Mary averages 4.5 miles per hour. Because of that word per, this is a linear function. The second statement, a submarine descends at a rate of 100 feet per minute. So once again, that keyword per is telling us we have a linear function. So we can go ahead and circle it. As it runs, a rabbit maintains a constant speed of 15 meters per second. So once again, we see that key raised for per. So we're going to circle it. And then we have our last statement, the area of a rectangle as the dimensions double. So although there is a relationship here, because we're talking about area is not linear. This is not a linear function. So the x squared and area. Question 27, we're being asked to write an equation for a line that has a y-intercept of -2 and a slope of 0. So we have two key pieces of information. The y-intercept is 0, -2, which means we have a b value of -2. That's where it's going to cross the y-axis. The slope of 0, so we have an m value of 0. We're writing an equation of a line. The equation of a line is going to be in the form of y equals mx plus b. And then from here, we can go ahead and substitute in the values that we know. So we have our y is going to equal, instead of m, I'm going to input my m value of 0, x plus, and I know my b value is -2. Now this can be simplified because anything times 0 is 0, and a plus negative would just be a minus. So we could have our final answer, 0 minus 2 is -2. And this is our equation of a line that has a 0 slope and a y-intercept of -2. On question 28, we're asked to find the slope from tables. You have finding the slope, you can use the slope formula. Your slope is going to equal y2 minus y1 divided by x2 minus x1. So we need the change in the y value divided by the change of the x value. When we have a table, I have a lot of students who like to look at from 4 to 2. -4 to -2 is an increase of 2. -2 to +1 is an increase of 3. 1 to 4, increase of 3. 4 to 6 is an increase of 2. So although these are different, that doesn't mean that it's not linear. We can still determine the slope. On the right side, we're going to do the same thing, and we should see a similar pattern. So on the y values from -2 to +0.5, that is going to be an increase of 2.5. That's hard to see. If you're having difficulty there, you can always use your calculator. You would do kind of like what's over here, the second y value minus the first. So this would be 0.5 minus -2. Here you're going to do 4.25 minus 0.5, and that's going to be 2.125. So this is positive 2.125. Then from 4.25 to 8, that's going to be 8 minus 4.25, which comes out to 375. And then from 10.5, subtracting the 8, that comes out to 1.5. And we'll notice, excuse me, not 1.5, 2.5. We'll notice that these are different. So this one doesn't have a constant slope, making it not linear, because if we take our values of 2.5 over 2, it's not going to give us the same thing as 2.125 over. So this one's not linear because we're getting different fractions, but we can find the slope from one point to another. So the next one, this 3.75 goes with, so this 3.75 goes with this 3. So the slope for that point, the change would be, and then of course you can put these in the calculator and reduce it. And then the last one we already have, this one does match the original, so we have that one already here. I'm going to go ahead and shift my attention to the second table. To give me space, I'm going to start off with a clean slate. Okay, so on the second table, we're going to do very similar. We're going to look at the change in the values. From -7 to -4 is an increase of 3. -4 to -1 is an increase of 3. -1 to +3 is an increase of 4. 3 to 5 is an increase of 2. So this one might be linear depending on what our slopes are on the y side, the change in our y's. So once again, if you're looking at the negatives and you're doing the change, you're going to follow the formula here. The second y value minus the first. So if you're typing this in the calculator, it's going to be -8.2, and then you're going to subtract a -10.6, and that comes out to a positive 2.4. Same thing here from these values. The -5.8 is my second y value, so -5.8 minus -8.2 is going to come out to 2.4. Oops, put a 3. And then the next set, we have -2.6, and we're going to subtract -5.8. That comes out to 3.2. And then our last one, we have -1, subtract -2.6, and we get a positive 1.6. So here, once again, we see the y values, 2.4 over 3, 2.4 over 3, but down here, oh, I messed up. This should be a 2. So it might work. So let's go ahead and type this in. 2.4 over 3. And that is going to come out to 0.8. And then we want to see, what about 3.2 over 4? So we have 3.2 divided by 4. That also comes out to 0.8. And then we go back to the last one, 1.6 divided by 2. And we'll see that that is 1.8 as well. So here we have a slope of 0.8. Question 29 is asking us to define the slope of this graph. So when you're looking at a graph, slope can be found by rise over run. Rise because that's the change in the y values. Run would be the change in the x values. So we're going to find a point. So we can use the y-intercept here because that line goes through right in the corner of the squares. So we're going to use that point. And then looking, we can see where else does it cross in the corner. We keep going. We see we have the point 2, 1. It's crossing right in the corner. So that's going to be the second point to use. And then from here, it's rise first. So we're going to go up. See, we're going up 3 units. Run is across 2 units. So our slope is equal to 3 over 2, and you can leave it as a fraction. Make sure that you notice that the line is going up from left to right, making the slope a positive value. That's one thing you can do when you're looking at your answer choices. You'll have some that have maybe a -3/2 as an answer choice, and you want to make sure that you don't mark that because the line is going up. Question 30 is asking us to graph a line with a slope of -1/2 and a y-intercept of 3. So we have our m value is -1/2. That means the line is going to go down from left to right. And we have our y-intercept is a 3. Starting off with the y-intercept, remember B is where you begin. This is on the y-axis. So we have our point on the y-axis at 3. From here, we're going to move with our slope. We're going to go down 1 over 2. 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 Don't forget to get the points on the other side. Up 1, back 2. Up 1, back 2. Up 1, back 2. All the way through the end. And then you'll notice, if I zoom back out, you have a line that is going down from left to right. Question 31 is asking us to find the rate of change and then also explain what it means. Rate of change is another word for slope. Once again, we have a graph, so we're looking at our rise over run. So from our y-intercept to our x-intercept, we have a decrease of 600 and going over 9. This will reduce to -200 over 3. So what this means, remember, the numerator is the change in the y values. This is the change in the x. So when we come over and we take a look at the graph, the y value is being represented by the amount of money. The refrigerator is decreasing in value $200 every 3 years. And it's 3 years because 3 is in the denominator, which goes with the x values, and x values is the years after it was purchased. Question 32 is asking us to complete the statement and we're focused on the characteristics of the parent function of a linear equation. This one is really important. You will see it almost verbatim on your test. So the first thing we start off is, what is the equation? The equation is y equals x because you have it's the simplest form. Or remember, instead of y, you could use f of x equals x. In looking at the equation, we can see we're talking about the slope. The slope would be the number in front of x. Remember, there's not a number you say, there's a 1, which means we have a slope of 1. If we were to graph this over on a coordinate plane, we would have our graph, the x and the y-axis. Because of the equation, we would begin at 0, moving up 1 over 1, On the other point, down 1 and over 1. And we can see this is our graph. When it's talking about the quadrants, remember it makes a C for coordinate plane. So the quadrants are numbered 1, 2, 3, and 4. So this graph is going to go through quadrants 1 and quadrant 3. All right, and that completes the second semester material. We'll move on now to the third cycle material.